Hello everybody, just so you know, I'm filming this at the end of the day, so the last bell is gonna ring pretty shortly, in like a minute, so sorry. But let's go ahead and get started on this. I'll stop when the bell rings, I'll pause. But, vocab. So today we're talking about graphing linear inequalities. So linear means lines, right? We're graphing them on a coordinate plane now, okay? It's very similar to graphing, there you go. Very similar to graphing linear equations. It's just now we have an inequality. So there are a few more steps that we have to take to do this, but one of the biggest steps is just graphing a line, and then we do a little bit past that, okay? So linear inequality is an inequality written in two variables. You guys, we're going to focus mostly on x and y, so those are the two variables you guys already know and are acquainted with. Solutions to linear inequalities are ordered pairs that make the inequalities true, okay? So it's an x and y that will make it true. So all this stuff, I know it's very wordy, and we'll apply it to the question so it'll make sense. But graphing linear inequalities is very similar to graphing linear equations, like I said already. However, because y can be either, not that one, equal to or not equal to, we can use a solid or a dashed line to represent the solutions. So just because it's on the line doesn't mean it's necessarily a solution. Just because it says x is greater than 4, 4 is not a solution. Because, sorry, they're really loud in the hallway. I hate doing it this time. Because the y can be greater or less than, we use shading either above the line or below the line to represent the solutions. Okay? No, it's a lot of words. It doesn't quite make sense. It will once we do a problem. Alright? So, this is a little, graphic organizer to help you remember. So a solid line is used when we have these two inequalities, either less than and equal to or greater than or equal to. A dashed line is either less than or greater than. Okay? Shading above is when it's greater than or equal to, or just greater than. And we shade below when it's less than or equal to, or less than. This also might be a topic that we need to spend a little bit more time on in class, which of course we will. So if you have questions, you're not sure, please write them down and we will go over them, okay? So there are steps to graph a linear inequality. First step is to solve for y. So it looks like slope-intercept form, y equals mx plus b. It's not going to have an equal sign because it's an inequality, but it should be like m times the x, slope times the x, plus the y-intercept. Okay? I apologize if someone walks in. They might be asking me a question at the end of the day. 2, we graph the line using the y-intercept and the slope, just like graphing a normal line for an equation. We figure out if the line is solid or dashed based on the inequality sign we used here. And lastly, we shade either above or below based on the inequality sign we had here. Okay? Now, I don't want you to forget Hoivux, which deals with the horizontal and vertical lines, because you will see those as well. Alright, next page. Now I do have a few more vocab words I forgot to put on your notes, so please write them down somewhere. Okay? It's not vocab we're going to see very often, but you do want to know it. A half plane is part of the coordinate plane that is shaded, so the half that we have the actual shading on, that's a half plane. A boundary line is the line that separates the shaded from the unshaded part. So that's going to be that's the line that you actually graph. Okay? A closed half plane means that we are actually including the boundary line as solution, so that would be a solid line that we have. And the last one is an open half plane, which does not include the line, so meaning it would have a dotted line. Okay? So again, these are not vocab words we tend to use very often, but it's important to know what they are. Okay? So example 1, we have to graph 2x minus 3y is less than 12. Okay, so step 1 was to get y by itself. So to do that, I'm going to subtract 2x from both sides. So now I have negative 3y is less than negative 2x plus 12. I'm going to divide everything by negative 3, which means if I'm dividing by negative, I'm going to have to flip my sign, okay? So now I get y is greater than 2/3 x, because the negatives cancel each other out, minus 4. Alright? So that gives me my y-intercept is -4, and my slope is 2/3. So I'm going to go ahead and graph that. So at 4, the line's going to pop up. I just know it, of course, because I'm trying to get these dots here. So -4 is my y-intercept. I can go up 2 and over 3, or I can go down 2 and over to the left 3. So then I draw my line. Now, the reason it's dotted is because of the inequality sign right here. Because it's not equal to, that's why I'm going to use a dotted line, okay? Just like an open circle, I would use an open circle if I was doing this on the number line. On the graph, I'm going to use a dotted line, okay? The last thing I need to do is the shading part. So I'm going to pull up a highlighter. Highlighter. Cool. Now, it says greater than. So greater than means that you shade above it, okay? So that's where everything bigger than this is happening. So I would just take my pen or a highlighter or something and shade all of this whole graph that's above the line, up and down, up and down, up and down, up and down, up and down. It doesn't have to be perfect, just shade it in so I know which side you're talking about. So clearly mine is not the prettiest thing, but so it's everything on this side of the line. Because the reason we're shading it is because all of these points that are now in yellow, these are all ordered pairs that if I plugged in the x and y here, it would come out to be a true statement, okay? All the stuff in the white, if I plugged in, would not make sense, okay? All these dots on the actual line are not solutions here because they would not make sense. So a good thing that you, like a thing that might help you understand it, is pick a couple points. Pick a point that's on this line, pick a point that's up, like in the white part, and pick a point that's in the yellow, and you can see it, okay? And that way you can tell which ones make sense as solutions, which ones don't, okay? There are lots of different ordered pairs, clearly, in this yellow part, that will make sense for this, okay? So that's why we can't just go ahead and write them all out. We have to graph them so everyone can see. So now you're going to try this one on your own. You do have a graph. I just didn't put it here. So you're going to graph this one on your own, okay? And we will go over it in class. All right? All right, example 2 is the reverse way. So I gave you a graph here, and I want you to write the inequality, not the equation, the inequality. Oh, I don't like that it says that. No, I want it in a pen, red pen. No, not that. An inequality. Inequality. Okay? So, to write this inequality, the easiest part is to get the parts that you need for slope-intercept form. Okay? And we just get that from this line. So, first thing I want to look at is the y-intercept. It's crossing right here at the 2. That's my b. I'm going to go ahead and figure out the slope. So if I go up 1 and over 2, up 1 and over 2, that is my slope. So slope is 1/2. I notice that it's shaded above the line. And I know that it's dotted. Dash, dotted, whatever you want to call it. Okay? That information is going to help me write this because the slope and the y-intercept tell me the slope-intercept form that it's going to be in. So it'll be y, some inequality, 1/2 x plus 2. The shaded above means that it's greater than, and the dash means it's not equal to. So my inequality is just that. The inequality sign I get from the shaded in the dash part, and the slope and the y-intercept make up the rest. And I just put a y in the front. Okay? So I want you to try this one on your own. Okay? Give that a try. We will go over this answer in class. Okay? And then the last one are special cases. So this is where Hoivux is going to play a big part. Okay? Why did I do it that way? Why did I cap only one? So Hoivux, remember, H stands for horizontal, the O is for zero slope, and it has a y equals equation. With vertical, V stands for vertical, undefined slope, and an x equals equation. Well, these aren't equations, these are inequalities, but the same thing happens. When it's x by itself is some kind of inequality to a number, that means it's a vertical line. Okay, so that's what I'm going to draw, is a vertical line going through -2, which is right here. Okay? Because it's not equal to, that's why I did a dotted line or dashed line. Okay? So, and then for shading, it says that x is less than -2. So that means I'm going to shade it where all the numbers of x are below -2, which is here. These are the numbers that are below -2. So this is the side that I need to shade. All of this. Okay? That's all I have to do to graph it. You guys are going to try this on your own, and yes, of course, you have a graph. Okay? So there's 3 try on your own. Give it a try. If you have any questions, we can certainly go over these more in class, because I do have the graphs on the board, so we can go over them, okay? But that's it for the video. It's not very long. It's 11 minutes. Alright? And then I'll see you next class, okay? Bye.